Here we're given 3 more problems on this forces review. So number 5 says that Jim is pulling at an angle of 20 degrees. There is no friction. Calculate the acceleration of the box. Okay, so first we need to go ahead and draw a force body diagram for the box. Well, it's going to have a force of weight that is being applied down, which is equal to mass times gravity, which for the box will be 100 newtons, because 10 times 10 is 100. And then we have an applied force, or a tension force, to the right of 15 newtons that the dog Ben is pulling on. And then we also have a force up at a 20-degree angle. But we need to resolve this into x and y components so that we know, okay, how much do we factor into the x direction and how much do we factor in to the y. Well, the way that we do that is we take our angle and we're going to say, okay, our x component, actually first we need to make sure that we are in degree mode. So notice here I am not, I'm in radians, so I need to switch over. Okay, so 65 newtons right here is the magnitude of this force on the rope. So into my calculator, I'm going to say 65 sine 20. Okay, and I get 22.2. So I have 22.2 in the y direction. Notice that this box is also on the surface of the ground, so there is a normal force being applied perpendicular to the ground as well. And then, for our x component, for this vector, force vector, we are going to say 65 cosine 20. And we get 61.1. Alright. So it says there's no friction, so we don't need to worry about friction, and it says calculate the acceleration of the box. Alright, in the y direction, it's not crashing through the floor, it's not popping up into the air, so our acceleration in the y direction is actually 0. Meters per second squared. In the x direction, though, we have 2 different forces. We have this 61.1, which is to the left, so it's actually negative, and then we have 15 newtons to the right. So the sum of our forces in the x direction are going to equal this negative 61.1 plus the 15 newtons to the right. And the sum of our forces equals mass times acceleration. Well, our mass is 10, and we're trying to solve for the acceleration of the box. So negative 61.1 plus 15, let's go ahead and plug that in. Negative 61.1 plus 15, and we get negative 46.1. And that equals our mass times our acceleration. Okay, well, if we divide both sides by the mass, we will get our acceleration, and it will end up being negative 4.61 meters per second squared. Alright, moving on to number 6. It says calculate Jim's acceleration and then calculate Jim's force. Okay, so basically Jim crouches on the ground and then pushes on the ground to jump off the surface. Alright, so at this point, the moment that he exerts a force on the ground, there is going to be a force of weight down. So he has a force of weight, which is mass times gravity, which is equal to 600. So 60 times 10. Alright, he also has a force a normal force that the floor has to apply back up on him to keep him situated on the ground. Okay, but if he is exerting a normal force on the ground's going to have to exert a greater normal force on him. So, we know that the net force is 800. Guys, if it gives you the net force, they're basically saying the sum of your forces equals 800. And we also know that the sum of our forces equals mass times acceleration. So 800 is going to equal 60 times A. So if we divide 800 by 60, we get an acceleration of 13.3 meters per second squared. Alright, and then calculate Jim's force. Alright, well, the net force is equal to 800. And we know that we have the normal force that the surface is going to have to apply up, minus the force of weight. So the normal force that Jim applies to the floor is going to be equal and opposite to the force that the floor applies to Jim. So if we know that the normal force that the floor applies to Jim is 600 plus 800, which is 1400, then we also know that he applies 1400 newtons to the floor. So that's the force that Jim's force that he uses to push off the ground with. Alright, number 7, calculate the acceleration on the box. Okay, so what we have to do is figure out, primarily since we know the acceleration in the y direction is 0, we're looking for what's going on in the x direction. So we want whatever this force is, some of it is to the right. We want to know how much. We do that by saying our hypotenuse cosine 30. So we're going to say 520 cosine, because it's at an angle of 30, and we get 450.3. So this is 450.3 newtons to the right. We also have a frictional force to the left. Well, the way that we find frictional force is we multiply mu by the normal force. Well, we have mu, it's right here, it says it's 0.25, but we don't know the normal force yet. Well, we know that there's a force of weight being applied down, which is equal to mass times gravity, so 800 newtons down. There's also an applied force right here in the y direction that is lifting up on the box, and there's also the normal force that the table's applying. We need to figure out that normal force. Okay, so we figure out the y component of this applied force by saying 520 sine 30. So 520 sine 30. And we get 260. So this is 260 newtons up. Well, we know that since it's not crashing through the table or flying up into the air, that these forces in the y direction are balanced, which means if you have 800 going down, you need 800 going up. Okay? Or, in other words, the sum of our forces should equal 0 since our acceleration is 0, since it's not moving in the y direction. So normal force is up, this 260 newtons is up, and then we have a force of weight which is 800 down, and that is all equal to 0. So we can move the numbers over to the other side. It will be 800 minus 260. So the normal force will end up being 800 minus 260, which is 540 newtons. Alright, now we can use that normal force to calculate our coefficient of friction. So 540 times the coefficient of friction, which was 0.25, is 135 newtons. So I know that I have a frictional force of 135 newtons to the left. Alright, so to find the sum of my forces in the x direction so that I can calculate acceleration, I'm going to say, okay, I have negative 135, because I have that much going to the left, plus 450.3, and that all equals 315.3. And the sum of our forces equals mass times acceleration. So the mass was 80, so 315.3 can basically divide by 80 to get acceleration. Therefore, acceleration equals 3.94 meters per second squared.